Hello everyone, and today we are doing the previous year questions of binomial theorem. Let's see what is the first problem. The least value of n for which the number of integral terms in the binomial expansion of cubic root of 7 and 12th root of 11 whole to the power n is 183, right? No. So whenever there is a problem of binomial theorem, no, so we'll start with finding the general term, right? How to write the general term here? The general term in this case will be written as r is equal to 0 till n, and this will be what? 7 n minus r by 3, this will become 1 by 3, right? And into 11 r by 12, right? No, to make it an integral multiple, no, so integral terms, what we need here, this should be the multiple of 12, the r should be that, and the first of the r can be 0 also, right? So r will start from 0 and it will go like 12, 24, 36 and so on. And how many terms are there? 183. So out of 183, no, one of the term will be 0, right? No, so what will the power of n should be? So just we'll multiply 183 minus this first term is 0, this will subtract, and rest will multiply 182 into 12. Just multiply 182 into 12 and see how much is coming. 182 into 12, right? Now 2 2s are 4, 2 8s are 16, 2 1s are, this will become 2 1 8, correct? No, so this is coming out to be 2184, right? Now 2184. So simply here the option will be what? B. N value should be what? The minimum value should be B, right? Now we'll move to the next question, and that is question number 2. Just see what is question number 2. So question number 2 is the number of integral term, the number of integral term, the number of integral term in the expansion of 5 to the power half plus 7 to the power 1 by 8 and whole to the power of 1016, right? No, so here also basically we have to find the integral terms, right? No, and the options given are a is equal to 127, b is equal to 129, c is equal to 128, and d is equal to 130, right? No, just see how we can approach this problem. Right now, so again we'll start with where? We'll start with writing the general term, right now. So that we can write as tr plus 1, and here the value is given as 1016. So tr plus 1 is equal to 1016 cr, and 5 to the power half is there too, so we'll write it as 5 to the power of 1016 minus r by 2, and this will become 7 to the power of, this will become r by 8, right? Now 1016, 7 to the power of r minus 8. Now for making it integral term, what should be there? This should be the multiple of r should be multiple of 8, right? Now starting with r is equal to 0, because here it is okay, right? Now 1016 and minus 8 and this, okay. So r here will be what? R here will be multiple of 8, and starting with where? Starting with r is equal to 0. Now see how many terms we will find. R is equal to 0 is one of the term, and then 8 and then 16 and so on, right? Now, and till where we will stop? We will stop till 1016, right? Now, so we will stop at 1016. Now 1016, the first term we will count as what? 1016, first term is 0, n minus 1, and d is how much? Right. So from here we will get 1016 divided by 8 is equal to n plus n minus 1. Done, no? This will become how much? 8 1s are 2, 8 2s are 16, 8 7s are 56. Right? So n minus 1 is becoming how much? 127. It means the total number of term will become what? n is equal to how much? 128. Right? No? So the final answer in this case will become what? 128. Done. This is again finding the integral term. Now we'll move to the problem number 3rd. Just see what is problem number 3rd. One more problem on the integral term we are finding. The number of integral term in the expansion of. Now I am doing the 3rd one. So the problem number 3 is the number of integral term in the expansion of 3 to the power half plus 5 to the power 1 by 4 whole to the power of 680 is equal to. 680 is equal to. Let's see how we can approach, right? The approach will be very similar to the last one only, right? How to write the general term here? Simply write 680 CR and this will become 3 to the power of 680 minus R divided by 2 and this will become here 5R by 4. Now again we try to find the integral term. No? So integral term, here R I want the multiple of 4, right? No? Because here it is okay, the number will be 680 minus 4 and all. This will be divided by what? This will be divided by, so focus on that side, right? So R will be a multiple of 4. So starting here, right now R is equal to the values of R which it can take is R is equal to 0, 4, 8, 12 and so on, and we'll stop till where? 680, right now. So again we will write 680. 680 is the total, right? 680. So directly we can do now. 17 4s are 68, right? So 170 term this and 0 inclusive is 171 term, right now. In 4 table now 170 into 4 we can write and this will become what? 0 is the inclusive term. So answer directly will become what? 171 terms, right? So this was your problem number 3rd.